it is not in the second quadrant. If tangent is positive, then the angle is in the third quadrant. So the angle they are talking about, theta, we are told that tangent is positive. Therefore, the angle should be in the third quadrant. Cosine is negative, the angle is not in the fourth quadrant. If cosine is negative, the angle is also not in the first quadrant. If cosine is negative and tangent is positive, then the angle is not in the second quadrant. You want to be able to do this elimination. You want to really be able to do this elimination before you start doing it. Okay, so because we can expand sine 2 theta, we can expand that, but what comes after that? Also, you can apply your Pythagorean theorem. So let me actually apply so many things you can do. It depends on what you like. So let me use Pythagorean theorem. I want everybody to look. I can just draw. Suppose there is a Pythagorean theorem somewhere, a right triangle somewhere, where there is a theta, and tangent of theta is opposite over adjacent, where the opposite is 4, the adjacent is 1. Because that whatever you know, whatever you can use. So the only thing I need to find is the hypotenuse. I can actually start from there. I'm given the value of tangent, and I can use it with the symmetry ratios in SOHCAHTOA in my right triangle. Okay, now I can find x. So by the hypotenuse is equal to the sum of the squares on the legs. Therefore, the hypotenuse is equal to square root, positive square root, or I can say plus or minus. 4 squared is 16, plus 1, that's 17. And therefore, I have square root of 17. Now, we know the angle is in the third quadrant. So, since the angle is in the third quadrant, only tangent will be positive. Well, since I know now that I found a, and x is square root of 17, I can find all the other trig ratios. Therefore, sine theta is opposite over hypotenuse, and cosine of theta is adjacent over hypotenuse. It's easy for me to find sine 2 theta now. So let's find sine 2 theta. I'm now going to find sine 2 theta. Sine 2 theta is equal to sine theta cos theta plus sine theta cos theta, or two, I can write both of them, sine theta cos theta. Or I can say 2 sine theta cos theta. Well, I already know the value of sine. I know the value of cosine. I just have to substitute. So whichever method is easier for you. So my sine theta is 4 over root 17. My cosine theta is 1 over root 17. And then I got to simplify. If I'm told to leave my answer in exact form, by all means I will. Okay, so let me open the parentheses. 2 times 4 is 8. Root 17 times root 17 is 17. Therefore, sine 2 theta is 8 over 17. The same thing with cosine of 2 theta. Same thing. All right. Any question? Yes or no? We have to do one more of this and we solve, let me see. We solve one quadratic trigonometric equation. By the way I just did number 21 is the way you do number 22. But I want us to solve one trig equation. Just in case we don't have enough time, we have 13 minutes remaining. Let me help you start with number 22 first. I'm going to help you start with number 22. it is still trigonometric sum and difference. Number 22 is still trigonometric sum and difference formula. They give you one identity. They give you actually find sine 2 theta, find cos 2 theta, and do not use calculator. All right. The only way they will know you did not use calculator is if you put decimal point there. Do not use calculator means leave your answer in exact form. That's what they are saying, including radicals. Okay, so okay. Anyway, let's go ahead and make sure we understand the question. So we are told that the angle cosine theta is greater than 0. Therefore, cosine theta is greater than 0. That angle must be in the fourth quadrant. Sine is negative. So the angle is not in the first quadrant. It's not in the second quadrant because sine is negative. It's not in the third quadrant because cosine is positive. Sine is negative, cosine is positive. If it is in the third quadrant, both of them should be negative. All right. Cosine is positive in the third quadrant and sine is negative. Therefore, the reference angle is in the fourth quadrant. So we are dealing with an angle theta in standard position in the fourth quadrant. You must know this. If you don't know what you're looking for, you won't even know when you get there. Okay, so I'm dealing with an angle theta in the fourth quadrant. So now I know that in the fourth quadrant, I know that all students take calculus, ST. Okay, so one thing I do know is that the other sine and cosine, by the way, they give me something else that will give it as a clue. Another clue is that even though the angle is in the fourth quadrant, they give me the ratio of sine. That works so well. So this is theta. I like using right triangle, but you can use something else if you like. I like using right triangle. So the clue I have is that sine theta is negative root 2 over 9, opposite to theta root 2 over hypotenuse. Don't worry about negative. I already know that this angle is in the fourth quadrant. So don't worry about negative. All I need to find is the missing side. If I find the missing side, the work is done because I can find the cosine. All right, so let's go ahead and find the missing side by Pythagorean theorem. So 9 squared by Pythagorean theorem is equal to leg squared plus leg squared. The square on the hypotenuse side is equal to the sum of the squares on the legs. All right, so this is 81. Square root of 2 squared is 2. I throw it to the left, minus 2 is equal to x squared. 81 minus 2 is 79. And so I can rewrite it as x equal to plus or minus square root of 79. If you don't agree, let me know. If I screw up, if I make a mistake, let me know. So I have x equal to square root of plus or minus square root of 79. Then I'm going to redraw this here. All right. The missing side is x square root of 79. The hypotenuse is 9. The opposite to theta is root 2. Well, I'm done because I already know everything in this right triangle. So I now have to expand cosine of 2 theta and cosine of 2 theta. So let me expand cosine of 2 theta quickly, and then the rest is history. Okay, so let's do that. So let's expand cosine of 2 theta and sine of 2 theta and substitute what we have and simplify. Okay, because we are told to solve for 2 theta. So I'm looking for sine 2 theta. Okay, so sine 2 theta. Be careful what you're looking for. I'm told to find sine 2 theta, right? That's what I'm looking for. So sine 2 theta is equal to sine theta, I mean sine theta, cos theta. So I can have 2 sine theta, cos theta. And I already know sine. Okay, I know the triangle already. So 2 multiply sine theta, opposite over hypotenuse, that is root 3/9. Cosine of theta is adjacent over hypotenuse, root 79/9. And then I'll simplify. Simplify and get your answer. Make sure that you are not simplify and get your answer. Okay, leave your radicals the way. If I'm looking for cosine of 2 theta, I know that cosine of 2 theta is cosine squared theta, because this is the same as cos theta plus theta, which is cosine squared theta. Cosine squared theta minus sine squared theta. All right, but I already know sine and cosine, so I plug them in here. What is, because the answer told me to find cosine squared theta. That's all. So I'm only finding the cosine squared theta that I'm told to find. So going to this triangle that I found. All right. What is cosine theta? Adjacent over hypotenuse, root 79/9 over 9 squared, 79, minus, what is sine squared theta? Sine squared theta, first of all, what is sine theta? I have opposite over hypotenuse, root 3/9, then square it. All right, so the job is actually done. So square root, so I'm going to have 79/81 here, minus square root of 3 squared is 3. Square root of 9 is 81. And I have 79 minus 3 will give me 76. 76/81 approximately will be my answer for cosine 2 theta. So I was told to find type an integer or simplify a fraction. So simplify this fraction and put it there, because my answer, the question is not asking me for any other thing but find sine 2 theta or cos 2 theta. Anyway, there's something here. I hope you know that this angle here is the same as you can have 180. Sine 180, 80 plus 180. Cosine 180 plus 180. So I think, what do we have? We got 4 minutes. That 4 minutes is enough to solve one quadratic. You can solve this one. But let's go and find one quadratic trigonometric equation. All right, this one looks good. I told you why I put this here. It's so that we can minimize what we are going to be dealing with in the next 2 weeks. Because in the next 2 weeks, we are going to be doing the polar coordinate, the complex coordinate. I mean, a whole lot of things, sine and cosine rule within all these things. So there's still a lot of things remaining, and 2 tests and 1 final exam. By the way, this is easy. If all the, I have quadratic trigonometric function, all right, but I can say let cosine of x be equal to a y or u. So I can rewrite this 8, I can just say u squared, 8u squared minus 16u plus 8 equal to 0. The next thing I want to do is divide all through by 8. So I have u squared minus 2u plus 1 equal to 0. The next thing is, can I factorize this? I think I can. Leading coefficient is 1. 1 times 1 is 1. If I have minus 1 plus minus 1, it's going to give minus 2. So I can have u squared. This is the way I write it though. Minus u minus u. That way I can do grouping. I like to do grouping. So I group this one and I group this one. And I have one common term will be out u into u minus 1 minus 1 here. U minus 1. What is in the parentheses? They are the same. So factorization works. So solving quadratic by factorization works here. U minus 1, u minus 1. So it's a perfect square. So I have u is equal to 1 twice. All right, but remember that there is no u in my question. But I said that at the beginning, cosine x is equal to u. So when u is equal to 1, cosine x is equal to 1. So I'm going to go around the, I'm told to use one cycle, one revolution. So within one revolution, in how many places do I have cosine equal to 1? What do I mean? In one cycle, in one revolution. Where do I have cosine equal to 1? You don't have to go too far to find it. Let's come over here. We have 1, 0 here. Cosine is the first coordinate. Cosine is 1 here. Therefore, my first answer is 0 degrees. And my second answer is 360 degrees. Two answers already. Is there any other place where I have cosine x equal to 1? Let's go. This is 0, 1. So cosine is 0 here. It doesn't qualify. This is negative 1, 0. Cosine is negative here. It doesn't qualify. This is 0, negative 1. It doesn't qualify. So these are my two answers. My two answers in one revolution are 0 degrees and 360 degrees. If I'm told to leave my answer in terms of pi, it will be 0 degrees and 2 pi. Any question? One more. It's 2 p.m. But we can actually, let me start number 30. There are 30 questions. I will select 15 again. 15 out of 30 questions and give you in the test in 2 days. And I will still select 5 questions from here. They could be repetitions and give you as a quiz. So there's going to be a quiz and a test. It opens in the morning and closes by midnight, both of them. I can just make the quiz 3 questions. That way you don't have a lot of time. But remember that both of them will open by 6 a.m., close by midnight. Okay, one last question. I want to start number 30. I want to start number 30. I'm going to start number 30.